the Monday, September 14th off-hour stream. Let's open it up. So you've all, actually, let me jump in on my iPad with Twitch, so I can follow along. All right. Now I'm on my iPad. Okay. Questions? Let's hear it. You all been working hard on the shell coding. On the sandboxing. What is up? There's Zoom chat. I keep forgetting the Zoom chat. Okay, several questions. Is there a good resource to find the argument options for the exit syscall? Yes. Man to exit. Let's take a look. Man to exit. All right. This is what it is. The argument is status. Boom. That's it. You just exit the status. The way it works is, let's okay. Move RAX 60, that's exit. Move RDI 42, that's the exit code. Syscall. We assemble it. We launch exit.elf, and here is the return value. This dollar sign question mark, it is a variable that the shell automatically creates with the return value of the last program to run. And there you go. So there's a question, but man doesn't have the status macros. Let's see what man has. The status macros. I have no idea what you mean by the status macros. Okay, so there's the semantic meaning of the exit argument, which, exit 0 typically means the program executed correctly. So if I do ls slash, that executed well. Exit 0. If I do ls slash blah blah, something that doesn't exist. Something non-zero means there was an error. Right? That's a typical convention. For your purposes, you don't care what the convention is. You're using exit to talk to yourself potentially, right? So you don't care about those macros. You can just exit with whatever you want. Otherwise, if there is a macro, do you have like a yes, exit success and exit failure? All right, we're gonna go through this. If there's a macro somewhere that that you want to look up, you can just include the right header file that defines the macro. You need to do that, and then you can just print the macro out. Here it is, exit success. And then what was the other one? Exit failure. I'm guessing because it lines up in size too. So that's nice and neat. Okay. Exit success 0, exit failure 1. By the way, this also works for other things like at fdcwd for some of the other problems. You need to include some other stuff. You can see what you need to include from the, I like to have them sorted by size. That's like descending. That's nice. Anyways, see what you have to include from the man page. And here's add CWD is -100. All right, so that is awesome. Let's swap back and forth because probably half the students are on the Zoom because there's only 17 people on, or sorry, half the students are on the Twitch. Actually, real quick before we keep going, let me send out a reminder announcement to the course. Don't forget about office hours happening now on Zoom and Twitch. All right, cool. So, let's swap to Twitch and then back. How does the buff from read work? So buff from read, here is read. It takes a buffer. It takes a file descriptor and it takes a count, right? It will read count number of bytes. So if you pass in 10, it'll try to read 10 or however many is available, greater than 0. So it'll wait until some data is available on this file descriptor and read at most count amount of data. It could read less. It can't read more. From the file descriptor provided, 0 for standard input or whatever other ones, and it'll store them into buff, and buff is a address in memory. That's it. That's all read does. So how level 10 is supposed to be done? Level 10, if you look at level 10, so let's bring up pwn.college. Whoops. Level 10. We still don't have the C download going, huh? Okay, level 10. If you launch it in practice mode, SSH in, all right, go into challenges, baby jail, and we look at level 10 teaching 1.c. All right. What you can see is level 10 only allows read and exit. All other syscalls are disallowed. So obviously, read is just a way to get data in, right? That's all you get. The only other thing you get is exit, and you need some way to get data out. Keep in mind, go look at the last part of the escaping seccomp lecture. I sincerely hope people aren't trying to tackle these problems without watching the lectures thoroughly. Look at the last part of that, and think, how can you get data out with exit? And also keep in mind that the flag's the same every time you run the program. If you can only get one bit out, you win, because you can just keep running again and again and again and get different bits out. Okay. And then the follow-up question, just having trouble figuring out how to store that. I'm assuming that means the flag, right? So when you read, obviously, the other hint, very important thing to keep in mind, is be aware of the order of operations, right? So, for example, level 10 first does the open. Oh, there's no seccomp. Oh, sorry, there's no chroot. So it first does the open, and then does the seccomp. So here, you can open any file you want. Go for it, right? So yeah, so you can open the flag. That gets you the flag being opened. So then you can read from the flag with read, obviously. And of course, the shellcode that you are working with is mapped writable. So you can write to that shellcode or write to the stack. So you can use that as your buffer. All right. Follow-up question. Let's stick with this. On level 11, you get a different set. Instead of exit, you get nanosleep. The question is, if you run nanosleep and then exit, will the sleep actually happen before the program dies because you tried to exit? Yes, it will. Seccomp isn't prescient. It doesn't look ahead. It just goes with the flow. As you try to execute syscalls, it'll check if you're allowed to. So it'll execute the nanosleep happily. It'll kill you as soon as you try to exit. All right, let's swap back to the Zoom chat. How do you decide which FD is going to be used in OpenAt? Where's OpenAt? Connor, we don't have AG on here. Is Connor on the chat participants? Man, Connor's just a Twitch guy. He's not on the Zoom. All right. Connor says, why would you ever use AG? You use AG because it's nice. It's fast. All right. OpenAt starts on level 4. Is our first time we see OpenAt. What does it do? Well, we're allowed to... No, that's the fake flag. We get to specify one file to open, and it can't be the flag file. It can't contain the word flag, right? And it can't be a link to flag. So no escaping that. So we get to specify the flag, a file to open. Then our shellcode runs. And all that our shellcode can do is open, add, read, write, and send file. So there aren't a lot of choices on which file descriptor to use in OpenAt. You either use standard input, standard output, standard error, some other file descriptor you pull out of somewhere magically, which you can do, or this path that you specify. And I mean, it should be fairly obvious that the intended thing to do is to use the path that you specify. Awesome. So that makes sense. Then let's swap back. There's a question about a tutorial on... Okay. Hint about number 9. Let's take a look at level 9. Okay, here's level 9. Actually, let's look at the testing one. All those prints aren't helping. All right, level 9, nice and simple. The crazy thing about level 9 is every rule except for, or every syscall except for close, stat, fstat, and lstat, up to syscall number 512, which is all the syscalls, are set up to kill the process. So you're only allowed close, stat, fstat, and lstat. All right, I'm going to give you this massive hint. This line is not present in any other challenge. It's present here. Figure out what it means. Rewatch escaping seccomp and use it. All right, let's see what else. Someone's saying, is there some sort of trick to using nanosleep? Yes, read the man page. Here is nanosleep. It takes a structure. You can't just call nanosleep. You have to give it a correct structure. So this is a pointer to data somewhere that you have to build up in memory. For example, push onto the stack. And in this data, you give it the amount of seconds and nanoseconds to sleep. And that's it. That's all you really need. In fact, this second thing where if the syscall is interrupted, there are various reasons why they can be interrupted, like your program receiving a signal. It'll actually update another place in memory with how much time it is left out of its original sleep amount. But that's fine. You can make rem null, so you don't have to build a structure for this guy. Just a structure here. Nice and simple. Build it up in memory, point RDI to it, done. The easiest thing, of course, is to play around with this in C and see what assembly is generated to build up the code, the data. Okay, back to Zoom. How does link at work? All right, let's look at link at. Man to link at. Link and link at makes a new name for a file. So that's pretty interesting, right? Sorry, my mind just went blank. Link at. So open at allows you to just open a file given a file descriptor, the directory, open a file relative to that directory. Link at is the same way, but it's slightly different in that it takes the file descriptor for an open directory, a path relative to that open directory, right? This is exactly like open at, right? But let me man to open at. Instead of opening this path relative to the directory, it makes a link, creates a new file on the file system that actually points to the same data, like a pointer in memory, so to say, right? Based on another file descriptor, which, by the way, nothing's stopping you from passing in the same file descriptor to both old and new file descriptor, referencing a directory file descriptor, and a new path. So that new path can be anywhere relative to the directory. Nice and straightforward. Kind of. Right? The level that gives you link at is level 5. Oops, that's the binary. All right, here's the link at level. What does it do? It chroots and chdirs. But before that, it opens a file of your choice. So far, it's exactly like level 4, right? And then it gives you link at, open, read, write, and send file. Level 4 gave you open at, read, write, and send file. Okay? So what's different? Open at was replaced with link at and open, right? You escaped from the jail using open at in the previous one. So it could be reasonable to assume that you use link at to violate the jail in some way. Then later you use open normally. Open on its own, in this scenario, I will tell you, cannot escape from the jail because the jail is correctly built, chroot and chdir. So our open call is going to be stuck in the jail. So logically, it follows that using link at, you can do something so that open, functioning properly within the jail, can still get you the flag. So what is that something that you can do with Linkat? Right? If you can't jump out of the jail, maybe you can pull the flag into the jail. All right. Let's look at zooms. Does seccomp block syscalls happening in the second stage execution of shellcode as well? Yes, absolutely. In fact, it goes further than that. Seccomp will block will block the syscall it blocks of the children of the process as well. There is no way within the same process tree to escape seccomp. Someone has a question. Can't seem to exit jail with OpenAT. Just still under the confines of CH root. I think we... Okay, I see. Later on down, this person is less confused now. That's good. Okay. Trying to call send file with execv at, and I get the flag with strace, but the actual challenge prints nothing. I think it depends on how you're running the actual challenge. I'd have to see the call or the trace. There's not enough information in that question quite yet. All right. Any level 12 tips? What is level 12 again? That's the binary. All right. Level 12. All you get is read. So, you can read the flag, right? There's nothing stopping you from reading a flag. Nothing here filters flag or anything. And then like level 11 and 10. But that's it. That's all you can do. You can't call sleep. You can't call exit. Any other thing you call will just force your program to crash. Or will force your program to get killed. But all you need to do is get one bit out. With level 10 and 11, you saw that all you have to do is get a byte out. Level 12, give you a hint, all you can do is get one bit out. A yes or no, a 1 or a 0. How do you do that? So the only thing that's important is from the outside, you, as the human observer, can tell the difference between the first bit of the flag being a 1 versus a 0. Figure that out and you've solved the challenge, because then you can just as easily adapt that to the second bit of the flag, and the third bit of the flag, and the fourth bit of the flag, and the fifth bit of the flag. You can, through multiple executions, right? However many bits the flag is long, that many bits is how many times you have to keep executing and then put the flag together. It's exactly like 10 and 11. Just much less throughput in your side channel. Yeah, so question is, do you have any tips for automating it? Yes, use pwn tools. So in pwn tools, you can use, do we have IPython? Okay, here's pwn. I can create a process. Let's just do bin cat. Oops. And I can talk with this process. And of course, it's bin cat. Oh, gosh, freaking Python 3. It's bin cat, so it's going to just cat back what I print to it. Hello. Oops, you're right. Oh, what the hell? Oh, this probably didn't flush. So, okay, now that flushed. Now this should work. There. There is caching at all levels of communications in Linux, in libc itself, in Python, in the kernel when pipes are concerned, like standard input and so forth. So when you write, it might queue it up but not actually do the write, which is super annoying. When you're running into situations when you think, okay, this should have been written out, what's going on? Try to flush the file you're interacting with, and then it should go through. So here, let's review what I did. I loaded up bin cat as a process. I wrote hello as a byte object, flushed it, and then I read it back out as a from standard out. So this is me communicating with the process. I can do stuff like close standard input. Now cat will terminate. For example, cat terminated, and I can see that it terminated with process 0. And I can get the process return code, and here's with 0, right? Just an example of launching a process, interacting with it, and seeing the termination code. Yeah, so you definitely want to, and this is all programmatic. I can launch, so if I do history, now I can do stuff like, hold on, I don't have my IPython profile on here, and I don't know how the default things go, so let me, profile default, I'm looking it up in a different, here's the config. Thank you. Okay, now it's in. Let me configure IPython properly real quick. Maybe we should make this the default counter. Okay. Here we go. This makes IPython usable. All right. Now I'm in VI mode, so I can interact with this just like a text editor, so I can write big scripts. So if I want to launch cat 10 times, pwn.process bin cat r.stdin.write. Let's just write the file, this is a format string that basically just says write the number into cat, stdin.flush. I can print the std out, read up to 10 bytes from it, but it'll only read, of course, what's available there, which would be less than 10. It'll be just the printed string representing that number. And let's do close stdin, wait for the process. Okay, run this 10 times. This doesn't return where I exited. r.proc.return code. And there I've scripted. Oops, I forgot to wait. Wait for the process to exit. Boom. And here I've scripted. Why is this none? Okay, that's weird. Let's just sleep for a second here. When in doubt, just put in some sleeps, let the system catch up. Oops. In module time. There we go. It's happily printing out stuff to us. See? So I'm running 10 times. Cat, printing in the number, the iteration number. It prints that back out to me, excuse me, and then it exits with 0. Very cool. In the same way, now I can add more logic. You can imagine that this I might actually be the bit index you're interested in, or the byte index. Here, you launch the challenge instead of cat. Here, you write a customized shellcode to get the specific bit instead of, just the index. And then here, instead of just printing out the return code, you check the return code and build up some knowledge based on that return code. Nice and simple. But it is very doable. Awesome. Okay. I highly recommend getting very familiar with using pwn tools in Python. It's very, very powerful. Okay. On Twitch, the real Adam Dupe asks, is there a hidden benefit to using IPython that Vim doesn't offer, or is it just a preference? It's a little easier to modify the script and run it immediately, right? In Vim, you have to modify it from a different terminal, run it. There's no real benefit, but I tend to build out scripts like this quickly in IPython, especially in Vim mode. It has all of the, I can hit K to go up, J to go down, L and H to go left, right. Vim users, tend to do that for speed over even the arrow keys. It's just nicer than normal IPython, and oops. Except for sometimes this terminal gets confused between insert and navigate mode. Why is that? Anyways, we'll figure that out. Okay, back to Zoom. Give a hint about 9. We went through that, right? Did I already cover 9? I think I covered 9 earlier. Level 1 testing. Yeah. So TLDR for 9, understand very, very clearly what this does. This line only appears in level 9. So obviously it is critical to the solution. Okay. Okay, there's a question about challenge 2 and challenge 11. Let's take a look at challenge 11. I vaguely feel like we already talked about it. Yes, we already talked about challenge 11. Just keep in mind, in challenge 10, you used exit to retrieve the flag, and challenge 11, you have to use nano sleep. Okay, so question. For level 2, so let's look at level 2 again. Do you have to use openat in a send file call? Syscall 322. What is syscall 322? Oh, exec_ve at. Okay. So this person is using exec_ve at in their shellcode to retrieve the flag. I guess that will be much easier. Will that even work? I think you're just... so you can use exec_ve at. Trying to think of what will happen. I think the new program should also run with the same chroot and then fail to load its libraries, is my guess. I would try... exec_ve at is overcomplicating level 2. Level 2, keep in mind, is exactly the same as level 1 with one difference. So if you diff level 1 testing 1.c and level 2 testing... What's going on here? And level 2 testing 1.c, the only difference... okay, there's a couple differences. The big difference is level 2 lets you open a file. That's one thing. And level 2 has you enter shellcode instead of just a file name. But keep in mind that the way that level 1 and level 2 build the jail is the same. Here's level 1. Just chroots, no chdir. Here's level 2. Also, they're just chroots. Change root, no change dir. Right? So you can write shellcode for level 2 that does exactly the same as the solution for level 1 did in the binary itself. strace that, and then write that as shellcode for level 2. That the intended goal from level 1 to level 2 is to write shellcode to do the same thing. Right? Cool. Just as a hint, I don't think open at is necessary either for level 2. No, sorry, I lied. It is necessary, of course. Just write syscall 2. No. strace level 1 and see what level 1 does after. So again, the difference is here. This, you just need to basically write shellcode for this. Oh yeah, yeah. You shouldn't even need open@. Cool. Okay. Let's take another one from Zoom. How to escape with mkdir. This is one of my favorite levels, right? Because this shows that why do I have... Oh, okay. This shows that chroot is not a sufficient sandboxing mechanism, right? If you don't also use seccomp very, very carefully. So, what happens here? We properly make the chroot, right? We chroot, and then we chdir into the new slash. We're locked in, right? And all we get is chdir, chroot, mkdir, open, read, write, and send file, right? We've seen, in comparison to, for example, the link at example, where link at is what you use to pull information from outside of the jail, and then open, read, write, or open and send file, if that's your preference, are used for the actual retrieval from within the jail. This is kind of analogous, right? using these three, chdir, chroot, and mkdir, you can escape. Watch my chroot lecture. There's one slide that I talk about. Chroot has no memory. When you chroot, your old chroot is forgotten completely. What happens if your new chroot wasn't set up properly? Don't get stuck in this thought that if you have a chroot within a chroot, then you have to escape first the inner and then the outer chroot. Once you create the inner chroot, the outer chroot no longer exists. Period. It's gone. It's forgotten. All you have to escape is the inner chroot. It's like, imagine you're stuck in a jail, and there you have a cardboard box. So you lock yourself in the cardboard box, and then the outer jail ceases to exist because the universe can only track one jail for you at a time. Then, of course, you can break out of the cardboard box. Awesome. Back to Twitch for a second. Help with link at. We did link at. Watch the VOD. If we have time, we have 15 minutes, and then I actually have to go this time at 4. How to hack VBox. Maybe we'll get to that later in the course. All right, if I missed something, let me know. For level 8, if you don't have a path to specify, I think I missed level 8, right? Level 8 is a beauty. All right, here's level 8. It builds the chroot. Creates a fake flag just for fun. And then it runs your shellcode with a seccomp where you only get open at, read, write, and send file. But you can't specify a path like the other levels. All right, for this one, thoroughly read the module page on pwn.college. All right. Where is it? Here. I'm going to go pwn.college. Go to, scroll down to the modules. Go to sandboxing. Read these tips and tricks extremely carefully. The answer is in there. Someone says 8 made me feel very smart when I figured it out. That is great to hear. Yeah, read that errata. It's good stuff. Link at tips. Check out the VOD. If we really stall out for questions, I'll go through link at again. Otherwise, yeah, check out the recording. We went through it earlier in the thing. I mean, unless there are no other questions, and then we'll roll for link at again. What's up? We got a voice question. Yeah. Question is, what is @_FDCWD? All right. Basically, in the man page, it states this interesting thing. This is the man page for OpenAt, and it says if path name is relative, as in ... or just a name, right? And dirfd is the special value at fdcwd, as we saw. I I made this macro.c earlier in office hours, where I just printed out this macro. This value is negative 100. If you pass in negative 100 to link at, open at, the various at system calls, they will resolve their argument relative to the current working directory. What happens is in the Linux kernel, for your process, there is a working directory that is implicitly open. For my shell, for example, I can go to proc self. This has a bunch of infrared, like my memory mappings for bash, right? So here's bash, and it has libc mapped in, and a lot of very neat bash stuff. Okay, anyways, we also have the current working directory, which is right now in this proc / my process ID, right? Okay, let's go back. That current working directory, it's not a file descriptor that's explicitly open. Actually, if I go back here and look at the file descriptors that are open, here is 0, 1, 2. So this is standard in, standard out, standard error. And then 255 for some reason as well. No idea what that's about. I can also, with bash, open other file descriptors. So I can open file descriptor 128. And just say, okay, let's open this to /flag. So I have file descriptor 128 open now. I could read from 128, right? There's an implicit file descriptor with specified by passing negative 100 to open at, link at, the at system calls, and that is this CWD thing. It is not an actual file descriptor opened by your process, but the kernel tracks the current working directory. You can actually figure out what the current working directory is using the get CWD system call. In bash, you can type pwd. It'll tell you the current working directory by, getting the using that system call. Whoa, hold on. Okay, yeah. Yeah, and actually you can, if you're interested in, if there's been pwd, you can see how it works. Here it does. It uses the get CWD system call and then prints out what it received. Very cool stuff. Okay, anyways, that is an implicit file descriptor. You can open at relative to it by passing negative 100. And that is relative to the last place you chdir'd into. And if your process never called chdir, then it's the last place that its parent chdir'd into, or its parent's parent, whoever last called chdir. All right, let's see. What's the meaning of life? We'll get to that if we have time. Getting bad address errors with nanosleep. All right. Very important. Nanosleep does not take the number of seconds to sleep. Nanosleep takes a pointer to a structure that should have two fields, one of which is the number of seconds and one of which is the number of nanoseconds. Okay? The first argument of nanosleep, needs to be a valid mapped address. Just like if you were passing a buffer to read. It needs to be either on the stack or somewhere else. It doesn't have to be writable. It can just be read-only, but it can also be writable. The second argument can be that address or an address or null. The second argument is where nanosleep stores the return. If it was interrupted, how much time was left. Interesting. That's how it does it. So Connor says on Twitch that bash keeps file descriptor 255 around. If we scroll up, there's this 255 that I have no idea why it was open. And you can see, actually, it's very cool. These are all open to my terminal. This is a device representing this terminal that I'm showing you. Anyways, 255 is open So you can redirect standard in, standard out, standard error, and you can still see stuff like Control C. Is this how it does sec faults? Hold on. Real quick, we need to let's, instead of exit.s, crash.s. Okay, that should crash. Okay, so if I run crash, okay, and if I even redirect, okay, what if I, how do I close? No, okay, I got all excited for nothing. Never mind. All right. Okay. Sorry about that tangent. I went crazy and went on a tangent. That's fine. Okay. Question: how do we determine if it's a valid address? Well, it's the exact same if you do a read to shellcode. How did you determine that that's a valid address? One easy way is look in GDB and see what the mappings are. Right? If you GDB whatever challenge, you break at start, or you break where your shellcode runs. You run, and then info proc map. Well, here's the mapping right now for this binary. Of course, the challenge will have more mappings, and it memory maps your shellcode, so that you can always use that as scratch space. For example, level 2 testing 1.c does this memory map for your shellcode into this location. So that entire page from 0x1337000 to 0x1338000 should be mapped. All right. Yeah, what's up? So, okay, so the question was, if I understand it correctly, let me repeat it back to you. Oftentimes when doing memory operations, you have to say keyword pointer blah. Is that what you're saying? Like move RAX comma keyword pointer, and then in brackets the thing. Do you have to use that when you are passing in, let's do this, exit.s, or let's say the argument, yeah, okay. So let's say we're building up an argument to read. What s's do we have? Let's look at stage2.s. This is exec bin sh, right? So are you saying you have to use keyword pointer here? Okay. So let's say that we are making space on the stack, so we're gonna call read. So we move RAX to 0, and we want to use RDI to 0, so that's read from standard input. We want to make some space on the stack, so we subtract OX100 from RSP, made space on the stack, and now we want to move RSP into RSI, so the second argument, the buffer, points to the stack, and we move RDX OX100, read 256 bytes, and then call the syscall. Not that here, you don't have to use keyword pointer or anything, right? The only time you have to specify the memory access size is if it's ambiguous. And nothing here is actually a memory access. Does that answer the question? Oh, it depends. So let's say you do this and you read in the flag, right? And then, so now your flag is RSI is pointing to your flag, and you want to read in read out the second argument, write out the second byte of the flag or something, right? If you can only write one byte, let's say. Let's set up the write. So we move RAX 1, move RDI 1. So this is write to standard out. Move RDX 1. So you can only write out one byte. And then if we do a syscall and we run this, it'll read out the first byte of the flag. So actually, let's do this all the way. What is open is file descriptor 2. Wait, did I just break something? No. Okay. Oh shit. No. Okay. Is everyone still there? Can you hear me on Zoom? Perfect. All right. Open is file descriptor, is syscall 2. We want to RDI. We open the file name, and here we do file name string/flag. You're right. Absolutely right. Thank you. All right, p plus file name, good catch. RSI will be 0, so just read only syscall open. Then we don't want to read from standard in, we want to read from whatever file descriptor open returned. Open returns its RAX is the return value, so we move RAX to RDI, and then this is open, read, and then write 1. We can assemble it. Okay. Here we go. Open, read, pwn.college flag, and write 1. You just get the P, right? Okay, and then let's exit cleanly so we don't look like amateurs. Okay. Boom. Just P. Okay. Now let's say we wanted to read the second argument, or the second byte. Well, that's very easy. RSI is pointing to the beginning of our flag. All we have to do is add 1 to RSI. Now it's pointing to the second byte. So now we assemble it, run it. Here's the W. If I do the third byte, add 2 to it, assemble it, run it, the N, and so on. And in fact, you can imagine if you're programmatically generating this, you could simply replace this with a format string for Python, for example. Or if you're a super hip person that uses F strings, there, for example. But you can generate this automatically. All right. Someone said on Twitch, I have to use the stack to call a syscall within a syscall. I have no idea what you mean by that. Absolutely no idea. I see what I closed earlier, the Zoom chat. Zoom question, any hammocks I recommend buying? Yeah, there's an awesome one. Unfortunately, we are out of time. Get hammock recommendations next time. All right, I have to go. I'm sorry about cutting off right at the end of the hour, but hopefully this was helpful. The VOD is available to watch, of course, and we'll put it on YouTube as soon as we can export it. Yeah, thank you for watching. If you have more questions, shoot us an email, pwn.college@asu.edu. Ask on Discord, or just shoot us an email personally. Otherwise, Connor will be streaming his office hours tomorrow at 2 Arizona time. Good luck. And the challenges, the practice problems are due at 4 Arizona time on Wednesday. Happy hacking. Bye-bye.